Today we're going to talk about inverse functions. And we're going to start that by talking about one-to-one functions. In order for a function to be one-to-one, each input has to have one unique output and vice versa. So each y, there is one x, and for each x, there is one y. That makes it a one-to-one function. We test that using the horizontal line test. Before we talk about the horizontal line test, let's review real quick what the vertical line test did in Algebra 1. When you had a graph of a function, you can drop a vertical line, and if it only touched in one place, that told you that it was a function. If it touched more than one place, then it told you that graph was not a function. The horizontal line test works similarly. You can drop a horizontal line on the graph, and if it touches in more than one place, the inverse will not be a function. So in this case right here, it touches in two places, so its inverse would not be a function. If I drop a horizontal line on this graph, each time it only touches in one place, so its inverse would be a function. Now, in order for it to be one-to-one, it must pass both the horizontal line test and the vertical line test. All right, so we're going to look at finding inverses now. We're going to start with this table. It says if a function f is one-to-one, then it has an inverse function f to the -1. I want you to get comfortable with this notation right here. This stands for inverse. That little -1 up on top stands for inverse. So using a table, we find the inverse function by switching the elements in the domain and the elements in the range. So the elements in the domain are x values, and the elements in our range are our y values. So we would switch those. So I would then have the point -27, -3. We have switched the x and the y. -8, -2. And that would be our inverse function table. So this is my f of x value. This is my inverse f of x values. We have switched our domain and range. We have switched our x and y values. That's the easiest way to look for an inverse. The next easiest is the graph. It tells us here that the graph of a one-to-one function f and the graph of its inverse f of -1, remember that's the notation for inverse, are symmetric with respect to the y equals x line. So the y equals x line is this line graphed right here. This is our y equals x line, right down the middle. That's the linear parent function, so everyone should know that one. So y equals x goes right through the origin here. And if we folded it right there, you would notice that this graph lands right on top of the other one. They are symmetric across that y equals x. That's exactly what that means. You can fold it on that line and they would both be the same on both sides of the line. It is symmetric across. That occurs when you're switching that x and y value like we did in the table. So here we had the point 83b3, and so it became b3a3. You have switched that x and y, giving you that graph that's symmetric. All right, so the one that takes more math than tables and graphs is the equation using the algebra. It tells us here to find the inverse and check the result. We replace f of x with y, and we interchange the variables x and y. So just like we did on the table, we switch that x and y. Then we solve for y, and we replace the y with f of -1x for the correct notation. In order to verify that two things are inverses, you can use compositions like we've done here. So f of 1 has to be equal to x, and f of -1 of f of x is equal to x. So if you do the composition with the function and its inverse, it will give you x. That tells you that it is an inverse. If it gives you anything else besides x, then it is not an inverse. All right, so we're going to practice finding an inverse. It tells us there that the first thing we need to do is use a y. So I'm going to go ahead and change that f of x for y. then we switch the x and the y. So I'm going to replace my y with an x, and I'm going to replace my x with a y. That's the inverse part. We switch that x and y. Now, y in math is considered the dependent variable, so we don't want to leave it in the equation. So we're going to solve for that y so that it's by itself. I add the 3 to get it to the other side. And so we get x plus 3 is equal to 8y. And then we divide by 8. And so we've got y equals x plus 3 over 8. That's our inverse function. Notice that it then says replace y by f of negative 1x. And so we need to replace it. And so this is my inverse function. We want that proper notation, which is that f to the negative 1x. That's my inverse. We'll go ahead and try a couple more just so that you can see it again. All right, step 1, I switch that to a y so that I have a y written there. I switch my x and y, so I get x equals 3y minus 5 over 2. I need to get rid of that 2. So we cross multiply and we get 2x equals 3y minus 5. I need to get rid of the 5. To get it to the other side, we add 5. And so we get 2x plus 5 equals 3y. And my last step is to divide by 3. Sorry about that, don't have a lot of space there. And so there is our inverse. I want to go ahead and write that with the proper notation. So I switch back to that f of negative 1x, and that is 2x plus 5 over 3. All right, for number 3, I switch my x and y, and so I've got x equals 4y squared minus 11. I want to get that y by itself, so I'm going to add the 11 to get it to the other side. That gives us x plus 11 equals 4y squared. I divide by 4. And so we've got x plus 11 over 4 equals y squared. Now, to get rid of a square, we take the square root. That's what's going to get that to cancel. And anytime that we take the square root of a square, we need the plus and the minus. And so we get y equals plus or minus the square root of x plus 11 over 4. Oops. Of course, we rewrite it with the proper notation. And there's our inverse. In most cases, they're going to restrict the domain on the quadratic so that it does give you a function, because this right here is not a function with the plus or minus. Plus or minus the square root of x plus 11 over 4 would fail the vertical line test, as a quadratic would fail the horizontal line test. So this isn't a function. In order to make it a function, we limit our domain. If you think about 4x squared minus 11, it would look like this. This fails the horizontal line test, so its inverse is not a function. So we usually limit to one side of the quadratic. So I would say to that right side. So you're going to see a domain restriction that looks like this. X is greater than or equal to 0. That would take away this left side of the quadratic. Then it passes the horizontal line test, and so our inverse would be a function. In that case, you would not need the plus or minus because we were only talking about the one side of the quadratic. All right, we're going to skip down here to this bottom part where it says to verify using composition. So one of these is the inverse. I'll go ahead and tell you which one it is, and then we'll do the verification so you can see the compositions. G of x is our inverse. So g of x and f of x are inverses of each other. In order to verify using compositions, we said it needs to be equal to x when we do the composition of the function and its inverse. So I need to find f of g of x to verify that that is x. I also need to find g of f of x to verify that that is x. If they are both x's, then they are inverses. If it is anything else, it is not an inverse. So f of g of x, my f function is 7x plus 4, and I am going to plug that g of x function into that. So I need to take this x minus 4 over 7 and plug it in for the x here. Remember, you're substituting that x, so that x should be gone. So we get 7 times x minus 4 over 7 plus 4. My f of x function is 7x plus 4. So this is 7, my new x plus 4. This cancels, and we get x minus 4 plus 4. Minus 4 plus 4 cancels, and we get x. You have to show all those steps. Don't just cancel everything on the first step, because the steps is what counts, and you want to make sure you're going in the correct order of operation. So you'll lose points if you just cancel everything at once. All right, for our g of f of x, I'm going to start with this one, and I'm going to plug in my f of x function here. And so I get 7x plus 4 minus a 4 over 7. I've taken this function and I've plugged it in for the x right here. So my g of x function is x, there's my new x, minus 4 over 7. The plus 4 and the minus 4 cancel out, so we get 7x over 7. And 7 divided by 7 is just 1, so g of f of x is equal to x. Since they're both equal to x, they are inverses. Again, if they were equal to anything else, they would not be inverses. So as a quick summary, to find the inverse, we switch the x and the y. In a table, in an equation, in a graph, it all works the same way where you're switching the x and y. For the horizontal line test, it tests to see if the inverse is a function. So vertical line test itself, horizontal line test its inverse to see if it's a function.